Hello and welcome to the EMC VNX Snapshots Introduction Series. Today, we'll talk about how to recover a SQL Server database with a consistent snapshot. This is the third video in the series. Please watch Provision Snapshot to a Virtual Machine and Snap of a Snap videos prior to watching this one. Just like with previous two videos, this one will consist of two parts. In the theoretical part, we'll talk about a consistent snapshot. We'll cover what a consistency group is and how a consistent snapshot is created. Why and how does a snap of a snap apply to a consistent snapshot? And is there any way to have individual attachment of portions of a consistent snapshot? And then we're going to go to the demo, where we're going to have a SQL Server database, live, doing queries. We'll create a consistent snapshot of the two drives that the SQL Server database lives on. We'll mount that consistent snapshot to a virtual machine, attach a database, and then compare the last entries in the databases to indicate that the snapshot has been consistent. A consistent snapshot is created when we have several LUNs, say two in this case, and they're uniting them into one single group. We can now snap that entire group at the same exact time, creating a consistent snapshot. When a snapshot is created, that means that VNX tracks consistent snapshot as a single object, regardless how many LUNs are inside the consistency group. However, we can still track the fact that there's different LUNs in the consistent snapshot, and we do allow individual subportions of the consistent snap to be attached. Snap of a snap concept applies to the consistent snapshot just the same as it would apply to a regular snapshot. For example, if we have a host with two LUNs attached, we can create a consistency group around those two LUNs. Then we can create a consistent snapshot for this consistency group. The consistent snapshot can later on be mounted to host 2. Note, for that operation we need two different snapshot mount points, or SMPs, one for every single LUN inside a consistency group. Later on, when host 2 has written down some data, the two SMPs can also be placed inside a consistency group, and another snapshot can then be taken of that new consistency group. This is snap of a snap. Consistent CG2 snapshot is a snapshot of CG snap. In other words, orange is a second level snapshot of purple. There are cases that one can think about where two different consistent snapshots need to be addressed at the same time. So here's an example. We may have a host 1 with two LUNs and a consistency group created for them, and the consistency group has two different snapshots, CG snap and CG snap 2. Now imagine this was a database. So we really wanted to mount the database portion from Monday and the log portion from Wednesday, because somewhere between Monday and Wednesday our database has been corrupted. But we really would like to roll forward the transactions from Wednesday and avoid the corruption. In that case, on host 2, we'll attach LUN 1 portion from Wednesday and LUN 2 portion from Monday. Of course, life would be too simple without some exceptions. Individual attach also has an exception. And it actually makes sense if you think about it. If my snapshot mount points on host 2 are put in the consistency group themselves, because we'd like to preserve what development is doing, for instance, then that consistency group cannot be attached to two different snapshots. However, they can still be happily attached to a single snapshot. And this makes perfect sense. If we have the SMPs in the consistency group, they should really be attaching to a snapshot that's consistent as well. But enough theory. Let's talk about the demo. Today, as with other examples, our demo is based on VNX 5700 with operating environment for block release 532. Our production server is Win2K8, release 2 service pack 1 with SQL Server 2012 installed. There's a database called CG test, and the database is created so that data and the logs are in two separate LUNs. We have a development system, which is a virtual machine on vSphere 5. That's also Win2K8 with Service Pack 1, and it also has SQL Server 2012 installed. Both systems have SnapCLI utility. This is my production server that's running SQL Server 2012. I have database properties right up, and you can see that the database CG test has two different files on it. The data is sitting on drive P, and the logs are sitting on drive L. Let's cancel this out. Take a look at Performance Monitor, and you can see that I have database running. If you look closer, you'll notice that my maximum transactions per second is 333 right now, and latest is 248, average is 138, 140. So let's minimize the performance window and run a little query. This query is going to list the last few rows of the database. Now, using SnapCLI, create a consistency group and a consistent snapshot with one command. I wrote a script, and here's the content of that script. It's a very simple script where we first run a SQL command that gives us, again, the same 5-6 entries from the database. And then we flush buffers of drives L and P. And then using SnapCLI create command, just one single command, we'll create the snapshot and the consistency group. So let's run the command, cg create.bat, give number 1. Takes a little time for it to run out and display the results. And here are the 5 last entries in the table. And at the end, we see that it has created a consistent snapshot called backup1.cg onto objects L and P. And here in the bottom, you see the current time. It's 13:31:07. And if you look a little closer, the last entry in the database is 13:31:03. This middle column in the database is nothing else but a timestamp, so that we have a little bit of an idea of what's going on there. And the only processes that I have are actually adding these lines into the table with an ID that's incremented, a timestamp, and then a timestamp of when the system started the SQL command. So you can see there's a little bit of discrepancy between the second column and the third column. Now we have the backup ready. Let's go straight to the development server and mount this consistent snapshot there. This is my development server, as you can probably read. And I have my SQL server started. Right now there are no databases here on the left. What we're going to do right now is go to command line and execute this script. Again, very simple script that takes SnapCLI and attaches backup number.cg. And notice these two flags over here. -F, we're forcing the attachment because by default, all snapshots have read-write flag disabled. And by forcing it, we're forcing the attachment and enabling it for the duration of the attachment. And -R0 means we're not going to be rescanning the entire SCSI bus because we're not adding new snapshot mount points. I already have 2 snapshot mount points provisioned in here. And the way these 2 mount points were provisioned are exactly the same how I've done in the other 2 videos. But we'll go to Unisphere right here in a second, and I'll show you that they've been provisioned the right way. In Unisphere, under host lists, we can see a list of hosts. We have ESX server selected. And on the bottom, when we click Snapshot Mount Point tab, we can see there's 2 mount points provisioned. VM-MP is my primary LUN, and logs-MP is primary LUN 2. Remember, when we looked at the production box, the logs for the database lived on LUN 2. So I made this mount point called logs-MP. And those mount points, besides assigned to host, are also being RDM provisioned to the VM. Back to development server. Let's go execute the command. And it is attach cg.bat. I'm going to provide an argument number 1. It's attaching the consistent snapshot, backup 1. Very simple. It's not rescanning the SCSI bus. The execution of the script takes a little while. I think it's a little quicker on the screen. We have two devices created when we attach this single snapshot. It's backup1.scg is attached in device E and device G. And now let's go to SQL Server and do a very simple attach a database. We will select the data file, MDF. Here in the bottom it tells us the drive L, which where the logs live, where it's not found, so we need to also give it the location of the log file, or the LDF, right here. Click OK, and CG test is right here. So let's go ahead and run a query on it. I won't be typing the whole thing, but here's the query. We're going to select everything from table 3, where my ID is greater or equal to the max ID minus 4, and we're going to order by ID. Just, again, simple query. The query is executing, and it should give us about 5 rows. And here the last row, if you take a look, the timestamp is 133103, and the ID matches exactly the last ID when the consistent snap was created, 272. And there you have it. We have attached a database that's been on the consistent snapshot, running on a different system without any issues, and it's been very simple with pretty much one command executed the attachment. To prove that I really had done it, let's go to event logs, go look at the application, click F5. Here are the SQL Server logs. We can see the first one says we're starting up the database CG test. There's about 4,000 transactions that were rolled forward in CG test. There were no transactions rolled back, and the recovery is successful. The transaction has been rolled forward. We have to realize that when the database is writing data, it first is written to the log. There's other transactions other than creating new data, and the database is not necessarily keeping the files always in sync on disk. There's an operating system layer. But the fact that SQL Server can recover information, and the fact that we can mount the entire SQL Server database with how many LUNs it had with one command and one consistent snapshot, makes this feature very effective. This concludes our third presentation. Thank you very much for your time.